Hello all, welcome to the next video in this TCP series. Today we will learn about flags, what different types of flags do we have and when do they come into play, as well as we will also learn about flow control wherein we will learn how windowing works. So let's get started. In the last few videos we have always come across three major flags. One is the SYN, the other is acknowledgement, and the last one is fin. So these three flags, as we know, that SYN and ACK, they always come into play when there is a three-way handshake between the sender and the receiver for a TCP establishment. The fin and ACK, they come into play when there is a three-way handshake for the TCP termination, right? Now, let's get or let's have a small recap of these three flags. So during a three-way handshake, we have a sender and we have a receiver. So the first message or the first SYN message is sent from the sender to the receiver. The receiver then acknowledges. The receiver acknowledges with its own acknowledgement plus sending a SYN message of its own, and the sender then sending back an acknowledgement. Right? This is SYN, SYNAC, and ACK, three-way handshake for TCP establishment. Next, we have a three-way TCP termination where the sender sends a fin flag or a finish flag to finish the TCP termination, right? The receiver sends a fin message of its own and also acknowledging the last fin message received from the sender. The sender then sends an acknowledgement of its own, right? So this is three-way handshake for a TCP termination. So this is when the SYN, ACK, and FIN flags will be set. Now, let us get inside other flags. When are they set? So the other flags are reset flag, push flag, and urgent flag. They are here. You have the urgent, push, and the reset flag. Let us understand when are they used. So let us understand when a reset flag is used. For example, let's say that the TCP connection that is existing between a sender and a receiver. Please understand there is already an existing TCP connection between a sender and a receiver. Okay. For some reason, any one of them decided to reset or start the TCP connection once again for some reason. Okay. So here also there will be a three-way communication between sender and a receiver. So whenever there is a three-way establishment, TCP establishment, whenever there is a termination, and whenever there is a reset of a TCP connection, there is always a three-way communication between a sender and a receiver. So here again, the sender sends a reset message saying that I need to reset this TCP connection. The receiver, okay, sends its own reset message with an acknowledgement of its own, and the sender again acknowledges this message received from the receiver. Okay, so we have a three-way communication for a reset, and in all these two messages the reset flag is set to 1. Now the next is the push flag. To understand this push flag, let us understand the mechanism behind the push flag. So A TCP connection is established whenever the sender and the receiver application needs a data transfer using a TCP process. So we have a TCP process on the sender side, and we also have a TCP process on the receiver side. Okay, so here, as we know that the sender application keeps sending data to the TCP process on its sender side. Similarly, the TCP process on the receiver side keeps sending to the receiving application on its end, right? So both these sender and receiver have something called as buffer, as I have drawn here, and we have also learned about their working. Okay, so today in this session or in this video also, we will learn about these buffer in a bit more depth. So what happens is that in this sender side, let us first go towards the sender side. This sender side application is sending data or information towards the TCP process. What the TCP process here does is it keeps storing all these data into its buffer. So just think that this is a buffer. I have drawn it in a circular manner or in a spherical manner because in the internet or whenever we go to any OTT platform, we always see a buffer. Whenever the video stops and it is buffering, we always see something in a circular motion. And that is why I have drawn this in a circular manner. Or you will see in many other example that the buffer is usually drawn in the form of a bucket to uh, make people understand it better. But I have drawn it in a circular manner. So the diagram or the visualization does not matter. The understanding behind this matters a lot. So the sender application keeps sending messages to the TCP process, and the TCP keeps filling these messages or data into its buffer. These small boxes that you see, you can understand or you can visualize it as different small chambers, okay, where data is being filled. Okay, and as the data is being filled, the TCP process is also creating segments. This is an example of segment where we have 1 2 3 4 5 6 7 8 9 10 bytes. This is a segment of 10 bytes. Okay, so the TCP process, as it is filling its buffer, it is also creating segments. Now the push flag, for example, the sender, as I had mentioned, the sender is continuously sending data to the TCP process, and the TCP process is storing those data in its buffer, simultaneously creating segments to send it towards the receiver. Now, for some reason, there is a data, okay, that the sender said that it needs this data to be sent in a priority. Okay, so what the sender application does is that, sorry, the sender application does is that it sets the push bit as 1 and sends it to the TCP process. Now, what TCP process does is that instead of storing that particular data in its buffer, these buffer or these empty buffers here, and what it does is that it directly moves it into the segment that is currently being created. Okay, that particular data is filled here, and the moment this segment is completed, it is sent to the receiver side. Now the receiver receives this priority data or priority byte, right, and it has a push bit set to 1. The moment the receiver TCP process reads this push data, it does not store it into its empty chambers. Rather than that it sends it towards the application on its receiving side. So what push bit does is that it tells the TCP process not to store that particular data or information in its buffer and send it towards the application. It can be the sender application or the receiver application. This push bit can be set by the receiver application also. The receiver might also want to send or share some information on priority basis, so it can also set that particular data as priority by setting the push flag as 1. So what in this case, what will happen, the TCP process here will not store that particular data in its buffer, and what it will do is it will send that particular data to the segment that is currently being created. And when the segment is sent to the sender application, the sender application will read this particular segment, see that the push bit is set to 1, will not it will not store it in its buffer, but directly send it to the sender application here. This is the work of push bit, to prioritize that particular information without having it stored in the buffer. Now the next flag is the urgent flag. As we know that the TCP process is actually a stream oriented process where continuous stream of data is being sent between the sender and the receiver. So before sending the stream, it actually creates a segment, fill all those, fill that segment with the data, with each byte of data, and when that particular segment is complete, it is sent. Okay, so let's again take the example where the sender is continuously sending some information, right? Now, please understand that this information is also being stored in the buffer as shown here. I will explain the meaning of these colors later when we are understanding the TCP flow control, but just understand that these colored boxes or these colored yes, the colored boxes mean that there is some data into them. So what the TCP process does is that it is continuously receiving data from the sender application, and it starts to store those data into its buffer, and it starts to create a segment so that it can send it to the other side. So let's imagine that it is stored in the buffer and it starts to fill the segment with data. So here I have 1 byte of data, we have another byte of data, third byte of data, fourth byte of data, right? Now suddenly the sender said, I need, there is a data that I need to send it urgently. Okay, what happens is that this urgent bit is stored in the buffer, is stored in the buffer, unlike push where it is not stored. Here it is stored in the buffer. When the buffer reads it, now what it does is that instead of putting that particular data in the next byte, the TCP process, what it does is that it creates or it sends the first byte, or it sets the first byte as this urgent data byte and pushes the other already created bytes or already filled information back. So we had 4 bytes of information already here, right? So this is how urgent bit plays. Now what happens once all these fields are filled, once all these bytes have information and the segment is complete, this is sent towards the receiver, right? So receiver would obviously see this particular urgent bit when it reads the segment first, right? Now, what happens is that the urgent bit in that particular segment is read first rather than the other segments being read. So segments are read in a sequential manner. So each of these bytes have a sequence number, as we have already seen in few of our older videos. Each of these bytes have a sequence number. So instead of reading these bytes in a sequential manner, the first byte that the receiver TCP process reads is the urgent byte, and it sends it to the buffer, and the buffer then sends it to the receiver application. Okay, so the difference usually in an interview they usually ask is that what is the difference between an urgent bit and a push bit. So when the similarity, yes, the similarity between these two is that these two bits are used to prioritize a particular data. Okay, the difference is that when there is a push field set, it is not stored in the buffer. It is it is not stored in the buffer. It is sent as soon as possible in the segment that is being created and sent, and the receiver then does not store it in the buffer and moves it to the receiver application. However, for the urgent bit, it is stored in the buffer, and the it is stored in the buffer, right? And when there is a segment being created, it is moved to the first byte in that particular segment, and it is sent across. When the TCP process reads it, of course, it is storing it in its TCP buffer. It reads it that it's an urgent bit in that particular segment, right? So the the first byte that is read in that particular segment is the urgent byte. Once first the urgent byte is read, then all the other bytes behind it, that is these bytes, all these bytes, they are also read, and then they are sent to the receiver application. Wherein push, all these other bytes are not read. The moment the receiver application sees the push bit as is set to 1, it sends that particular byte directly to the receiver. I hope I was clear. I will once again explain the difference between a push and the urgent bit. In the push field, or when the push flag is set, what happens is that the data is sent to the TCP process. The TCP process does not wait or does not store it in the buffer, and what it does is that it moves that particular push bit into the segment, and also it does not wait for the other bytes to be filled, meaning that you can think that a separate push byte is created separately for this push bit, and this push bit is sent. When the receiver reads this push bit, it sends it directly to the receiver. I hope this was a much better clarity on the push bit, where a separate segment is created for the push byte with a push bit set to 1, wherein with the urgent field or urgent data, this with the urgent field, what the TCP does is that it moves the urgent byte or the priority byte to the first byte in the segment. It does not create a separate segment for the urgent bit, but it moves it to the first byte of the segment. So obviously, when the TCP process reads that particular segment, the first byte that is read is the urgent bit. In push, a separate segment is created for the push data, but in urgent, a separate segment is not created, but the urgent byte is moved to the first byte or the first sequence or given the first sequence in that particular segment. I hope this was a much better clarity to understand what is the difference between push and urgent. Now, whenever there is an urgent byte or urgent bit or urgent flag set to 1, right, it is not necessary that the urgent byte is just 1 byte long. So here, for example, we have a segment of 10 bytes. Okay, now there can be or there may be a data that is 5 bytes long. Okay, 5 bytes of urgent data. So what the sender application does is it sets the urgent bit to 1, sends it to the TCP process. What the TCP process does is that it sets or moves all this urgent byte in the front of the segment, right, and sends it to the receiver side. Now, along with this, what the sender application or this sender TCP process does is that in the urgent pointer, there is something called as urgent pointer here, the urgent pointer. The work of this urgent pointer is to tell the receiver how long is that particular urgent byte. Is it 1 byte long, 10 bytes long, 100 bytes long, etc. Yes, the receiver understands that it has received an urgent information, but how long is that urgent information, right? So that is the work of the urgent pointer. It tells how long or how big the urgent byte is. Okay, so whenever there is an urgent bit set to 1, the urgent pointer tells how long the urgent byte is or the urgent data is. That is the work of urgent pointer. So along with urgent, there is always an urgent pointer telling how long the urgent bytes are. I hope this video was informational for you, and let us see. I will see you in the next video where I will be telling about TCP flow control. So have a great day, and I expect if anyone does not understand the flags, please do reach out to me via the comment section and I'll be happy to clarify them. So have a great day and thank you.